Welcome to the most comprehensive AI learning tutorial on YouTube. If you've ever wondered how artificial intelligence works, or if you want to build your own AI models from scratch, you're in the right place. In this video, we're going to cover everything you need to know about AI learning, from the absolute basics to advanced concepts. Whether you're a complete beginner with no programming experience, or an experienced developer looking to add AI to your skill set, this tutorial has something for you. By the end of this video, you'll understand what AI is, how machine learning and deep learning work, and you'll have a clear roadmap for starting your AI journey. So grab a notebook, get comfortable, and let's dive into the world of artificial intelligence. Let's start with the fundamentals. What exactly is artificial intelligence? At its core, AI is the development of computer systems that can perform tasks that typically require human intelligence. This includes things like visual perception, speech recognition, decision-making, and language translation. But here's the thing most people get wrong: AI isn't just one technology. It's an umbrella term that covers many different approaches and techniques. The field of AI was formally established in 1956 at the Dartmouth Conference, where researchers coined the term artificial intelligence. Since then, AI has evolved dramatically. In the early days, researchers focused on rule-based systems, also known as expert systems. These systems used if-then rules to make decisions. For example, if a patient has a fever and a cough, then they might have the flu. These systems worked well for narrow problems but couldn't handle the complexity of real-world situations. Today's AI is fundamentally different. It uses machine learning, which allows computers to learn from data rather than following explicit rules. This shift from programming to learning is what makes modern AI so powerful. Now let's talk about the different types of AI systems. Understanding these categories is crucial because they help you understand what AI can and cannot do today. First, we have narrow AI, also called weak AI. This is the only type of AI that exists today. Narrow AI is designed to perform a specific task really well. Think of it like a specialist doctor who is an expert in one area but doesn't know other areas. Examples include Siri, Alexa, recommendation systems on Netflix and YouTube, and image recognition systems. Every AI system you use today is narrow AI. Second, we have general AI, also called strong AI or AGI, which stands for Artificial General Intelligence. This is AI that can understand, learn, and apply knowledge across a wide range of tasks, just like a human being. AGI doesn't exist yet, but many researchers believe will achieve it within the next few decades. Companies like OpenAI, Google DeepMind, and Anthropic are actively working toward AGI. Third, there's superintelligence, which is hypothetical AI that surpasses human intelligence in every way. This is still theoretical and is the subject of much debate among AI researchers and ethicists. Machine learning is the backbone of modern AI. It's the technique that allows computers to learn from data without being explicitly programmed. The concept is actually simple. Instead of writing rules, you feed data to an algorithm and let it figure out the rules on its own. There are three main types of machine learning. First, supervised learning. This is where you have labeled data, meaning you know the correct answer for each example. You train the model by showing it many examples with their answers, and it learns to predict the answer for new examples. Think of it like studying for a test with an answer key. Second, unsupervised learning. Here, you have unlabeled data and the algorithm must find patterns on its own. It's like being given a box of mixed puzzle pieces and figuring out which ones belong together. Common uses include customer segmentation and anomaly detection. Third, reinforcement learning. This is where an agent learns by interacting with an environment and receiving rewards or penalties. It's like training a dog with treats. The agent tries different actions and learns which ones lead to the best outcomes. This is how AI systems like AlphaGo learn to play Go at a superhuman level. Deep learning is a subset of machine learning that uses artificial neural networks to model and solve complex problems. These neural networks are inspired by the human brain. Just like your brain has billions of neurons connected to each other, artificial neural networks have layers of interconnected nodes. A neural network has three main types of layers. The input layer receives the raw data, whether it's an image, text, or numbers. The hidden layers, which can be one or many, process the data by applying mathematical transformations. The more hidden layers you have, the deeper the network, which is why it's called deep learning. And the output layer produces the final result. The magic of deep learning is that these networks can automatically learn features from raw data. In traditional programming, you had to manually define what features to look for. With deep learning, the network learns the features itself. This is why deep learning has revolutionized fields like computer vision and natural language processing. Convolutional neural networks, or CNNs, are particularly good at processing images. Recurrent neural networks, or RNNs, are designed for sequential data like text and time series. And transformers, which power models like GPT and BERT, have become the dominant architecture for language tasks. Python is the most popular programming language for AI and machine learning, and there are several reasons for this. First, Python has a simple and readable syntax that makes it easy to learn and use. Second, it has a massive ecosystem of libraries and frameworks specifically designed for AI. Third, it has a huge community of developers and researchers who contribute to its growth. Let me introduce you to the essential Python libraries you need to know. NumPy is the foundation for numerical computing in Python. It provides efficient arrays and mathematical functions. Pandas is used for data manipulation and analysis. It makes working with structured data, like spreadsheets and databases, incredibly easy. Matplotlib and Seaborn are used for data visualization. They help you create charts, graphs, and plots to understand your data. Scikit-learn is the go-to library for traditional machine learning algorithms. It provides simple and efficient tools for data mining and data analysis. And for deep learning, you have TensorFlow and PyTorch. These are the two most popular deep learning frameworks. TensorFlow, developed by Google, is great for production deployment. PyTorch, developed by Facebook, is favored for research due to its dynamic computation graph. Before you can train any AI model, you need to prepare your data. This is often the most time-consuming part of any AI project, but it's absolutely critical. The quality of your data directly impacts the quality of your model. Data preparation involves several steps. First, data collection. You need to gather relevant data for your problem. This could come from databases, APIs, web scraping, or public datasets. Second, data cleaning. Real-world data is messy. It might have missing values, duplicates, or errors. You need to handle these issues before training. Third, feature engineering. This is where you transform raw data into features that are useful for your model. For example, if you have a date, you might extract the day of the week, month, or season. Fourth, data normalization. Different features might have different scales, which can cause problems for some algorithms. Normalizing or standardizing your features ensures they're on a similar scale. Fifth, splitting your data. You typically split your data into 3 sets: training, validation, and test. The training set is used to train the model, the validation set is used to tune hyperparameters, and the test set is used to evaluate the final model performance. A common split is 70% training, 15% validation, and 15% test. Let's build your first AI model step by step. We'll use Python with scikit-learn to create a simple classification model. The process follows a standard workflow that you'll use for every AI project. First, import your libraries. You'll need NumPy for arrays, Pandas for data handling, and scikit-learn for the model. Second, load your dataset. For this example, we'll use a built-in dataset from scikit-learn. Third, explore your data. Look at the first few rows, check the statistics, and visualize the relationships between features. Fourth, prepare your data. Handle any missing values, encode categorical variables, and split the data into training and test sets. Fifth, choose your model. For beginners, I recommend starting with simple models like logistic regression or decision trees before moving to more complex ones. Sixth, train your model. This is done by calling the fit method on your training data. The model learns the patterns in the data during this step. Seventh, evaluate your model. Use metrics like accuracy, precision, recall, and F1 score to measure how well your model performs on unseen data. Eighth, tune your model. Adjust hyperparameters to improve performance. And finally, make predictions on new data. This entire workflow can be done in just a few lines of Python code, which is why Python is so popular for AI. Computer vision is one of the most exciting applications of AI. It gives computers the ability to see and understand visual information, just like humans do. Computer vision is used in self-driving cars, medical imaging, facial recognition, augmented reality, and many other applications. The key technology behind modern computer vision is convolutional neural networks, or CNNs. CNNs are specifically designed to process grid-like data, such as images. They work by applying filters to the input image to detect features like edges, textures, and shapes. As the data passes through more layers, the network learns to recognize increasingly complex features, from simple edges to complete objects. Popular computer vision tasks include image classification, where you determine what's in an image, object detection, where you identify and locate multiple objects, semantic segmentation, where you classify every pixel in an image, and image generation, where you create new images using AI. Libraries like OpenCV provide tools for image processing, while frameworks like TensorFlow and PyTorch make it easy to build and train CNN models. Transfer learning is a powerful technique in computer vision. Instead of training a model from scratch, you can use a pre-trained model that was trained on millions of images and fine-tune it for your specific task. Natural language processing, or NLP, is the branch of AI that deals with understanding and generating human language. This is what powers chatbots, language translation, text summarization, and sentiment analysis. NLP has made incredible progress in recent years, especially with the development of large language models like GPT, BERT, and Llama. Traditional NLP relied on rule-based approaches and statistical methods. But modern NLP is dominated by transformer-based models that use attention mechanisms to understand the relationships between words in a text. The attention mechanism is the key innovation that made modern NLP possible. It allows the model to focus on different parts of the input text when processing each word. This enables the model to understand context and meaning much better than previous approaches. Key NLP tasks include tokenization, which breaks text into smaller units, named entity recognition, which identifies names, places, and organizations, sentiment analysis, which determines the emotional tone of text, machine translation, which converts text from one language to another, and text generation, which creates new text based on a prompt. The rise of large language models has made NLP accessible to everyone. You can now use APIs like OpenAI's GPT or open-source models like Llama to build powerful NLP applications without training your own models. Reinforcement learning is a fascinating area of AI where agents learn by interacting with an environment. Unlike supervised learning, where you have labeled data, in reinforcement learning, the agent learns through trial and error, receiving rewards or penalties for its actions. The key concepts in reinforcement learning include the agent, which is the learner and decision maker, the environment, which is the world the agent interacts with, the state, which is the current situation of the agent, the action, which is what the agent can do, and the reward, which is the feedback from the environment. The goal of the agent is to learn a policy, which is a strategy for choosing actions that maximizes the total reward over time. One of the most famous applications of reinforcement learning is AlphaGo, developed by Google DeepMind. AlphaGo learned to play the board game Go at a superhuman level by playing millions of games against itself. Another exciting application is robotics, where reinforcement learning is used to teach robots to walk, grasp objects, and navigate complex environments. Reinforcement learning is also used in game playing, autonomous driving, recommendation systems, and resource management. The challenge with reinforcement learning is that it often requires a lot of data and compute. Training an agent can take millions of interactions with the environment, which is why techniques like simulation and transfer learning are important. Let's explore the tools and platforms you'll use as an AI practitioner. Understanding these tools will help you choose the right ones for your projects. For development environments, Jupyter Notebook is the most popular tool for data science and AI. It allows you to write and run code in interactive cells, making it perfect for experimentation and visualization. Google Colab provides free access to GPUs and TPUs, which is essential for training deep learning models. VS Code with the Python extension is great for larger projects. For cloud platforms, Google Cloud AI Platform, Amazon SageMaker, and Microsoft Azure ML provide managed services for training and deploying AI models. These platforms handle the infrastructure so you can focus on the model. For model hosting and deployment, Hugging Face is the go-to platform for sharing and using pre-trained models. It hosts thousands of models for tasks like text generation, image classification, and more. For data, Kaggle provides free datasets and competitions that are perfect for practice. GitHub is essential for version control and collaboration. And for learning, platforms like Coursera, Fast.ai, and MIT OpenCourseWare offer excellent AI courses. The AI ecosystem is constantly evolving, so staying up to date with the latest tools and platforms is important. Training an AI model is both an art and a science. It requires understanding the algorithms, tuning hyperparameters, and knowing when to stop. Let me walk you through the key concepts. The training process involves forward propagation, where data flows through the network to produce a prediction, calculating the loss, which measures how far off the prediction is from the actual answer, and backward propagation, which adjusts the weights to reduce the loss. This cycle repeats many times until the model converges. Learning rate is one of the most important hyperparameters. It controls how much the model changes in response to the estimated error. If the learning rate is too high, the model might overshoot the optimal solution. If it's too low, training will be very slow. Batch size determines how many samples are processed before the model is updated. Larger batches provide more stable gradients but require more memory. Number of epochs is how many times the entire training dataset is passed through the model. Too few epochs and the model underfits. Too many and it overfits. Regularization techniques like dropout and L2 regularization help prevent overfitting by adding constraints to the model. Early stopping monitors the validation loss and stops training when it starts increasing. These techniques are essential for building models that generalize well to new data. Evaluating your AI model properly is crucial. A model that looks great on training data might perform terribly on new, unseen data. Let's talk about how to evaluate your models correctly. For classification tasks, accuracy is the most common metric. It's the percentage of correct predictions. But accuracy can be misleading, especially with imbalanced datasets. If 99% of your data belongs to one class, a model that always predicts that class will have 99% accuracy but is actually useless. Precision measures how many of the positive predictions were actually correct. Recall measures how many of the actual positive cases were caught. The F1 score is the harmonic mean of precision and recall, providing a single metric that balances both. For regression tasks, common metrics include mean squared error, or MSE, which penalizes large errors more heavily, and mean absolute error, or MAE, which treats all errors equally. Cross-validation is a technique for getting a more reliable estimate of model performance. Instead of a single train test split, you split the data into multiple folds and train and evaluate the model multiple times, using different folds for testing. The confusion matrix is a powerful visualization tool that shows you exactly where your model is making mistakes. It shows true positives, true negatives, false positives, and false negatives. AI is transforming every industry. Let's look at some real-world applications that are changing how we live and work. In healthcare, AI is being used to diagnose diseases from medical images, discover new drugs, and personalize treatment plans. Google's DeepMind developed AlphaFold, which can predict the 3D structure of proteins, a breakthrough that could revolutionize drug discovery. In finance, AI algorithms detect fraudulent transactions, assess credit risk, and power robo-advisors that manage investment portfolios. High-frequency trading uses AI to make split-second trading decisions. In transportation, self-driving cars use a combination of computer vision, sensor fusion, and reinforcement learning to navigate roads. Companies like Tesla, Waymo, and Cruise are leading this revolution. In entertainment, AI powers recommendation systems on Netflix, Spotify, and YouTube. It's also used to create realistic visual effects in movies and generate music. In education, AI tutors provide personalized learning experiences, adapt to each student's pace, and provide instant feedback. In manufacturing, AI-powered robots assemble products, predict equipment failures, and optimize supply chains. The potential applications of AI are virtually limitless, and we're just scratching the surface of what's possible. As AI becomes more powerful and pervasive, ethics becomes increasingly important. We need to ensure that AI systems are developed and deployed responsibly. There are several key ethical concerns in AI. Bias and fairness. AI systems can perpetuate or amplify biases present in their training data. If the data reflects historical discrimination, the AI will learn to discriminate. This has been seen in hiring algorithms, facial recognition systems, and criminal justice tools. Transparency and explainability, and that